Welcome to this module on developing for Azure. In this module, I want to take a look at the different development tools that you can use to work on Azure and the different tools that Azure provides for you. Specifically, we'll be talking about tools and technology. So what kind of languages can you use? What kind of tools can you use? And what kind of tools does Azure provide you to make developing on the platform easier? Now, when we think about developing for Azure, one of the key things is that this is a platform for a variety of different technologies. It's not just for Microsoft. So most of the services that are available have REST or web APIs that you can use. The storage service, for example, logic apps, functions, management, all of these things are exposed as services. And this provides cross-platform access, meaning that if you can create an HTTP request and send it, you can probably interact with those services. Now that said, that's not what most developers want to do, and so Microsoft provides client SDKs that wrap those APIs for you and give you a platform-specific interface, and they tailor that to the programming language. So things like HTTP requests and asynchronous work follows the common patterns on those platforms and with those languages. There are a few things where you can do development in the portal, such as logic apps and Azure functions, but most of those also have a mechanism for you to develop outside in a development environment, or at minimum, to be able to manage those resources, those code definitions of the function or the logic app, and be able to integrate them into your build and deployment pipeline. The SDKs are a big part of developing for Azure. This simplifies your development because you're not creating HTTP requests and making sure you set all of the headers correctly. You get to work with an SDK that's written for your programming language that simplifies and wraps that complexity for you. You also have a choice in developer tools. Certainly the Microsoft tools are going to work and they're going to give you a lot of functionality in working with Azure, but there are other developer tools that you can use. Some have more integration with Azure than others, but the choice is really up to you. One of the big things today is container development. And it's a bit of a high bar to get started and to understand all the moving pieces with containers and then to get it all working. And Microsoft in their tooling has tried to make that easier for you to simplify individual development for containers as well as team development. And finally, part of developing is going to be how do you build and deploy your application? We've seen that ARM templates and the Azure Resource Manager is one way that we can provision the environment. We also need to deploy our application code into that environment. So you can use various tools to do this, some provided by Microsoft. In other cases, you can use the tools that you're already using today. Those SDKs support multiple languages. So as I said, this isn't just about Microsoft and .NET. They want everybody to be able to develop for Azure. So you're going to find SDKs for PHP and Python and Ruby, and of course Java and Node.js. Many of these SDKs are cross-platform. So if the language that you're working on is cross-platform, the SDK itself has been built to be cross-platform as well. So it's a lot easier for you to manage. And if you're in a team where you've got people working on Windows and Mac, you want to be able to have everybody using the same SDKs, have the same capabilities. One of the things I will caution you about is that the service coverage varies in the SDKs based on the languages. Obviously, .NET has pretty broad coverage, as do Node.js and Java. Some of the other languages have very specific and tailored SDKs based on their common usages out in Azure. Just make sure you take a look at the documentation for your programming language and the SDKs that are provided so you gain an understanding about what services are available directly. And keep in mind, if they're not, you can still use the HTTP model and go against the REST API. I mentioned the developer tools, and of course Visual Studio is a great tool for working on Azure. It's got direct support. If you add in the workload for Azure or cloud development, for creating projects that are targeting Azure, for Service Fabric or logic apps, so you can add in the cloud workload, you can find extensions to Visual Studio for some of the other services, and you get integrated tooling inside Visual Studio for viewing and managing your resources. So being able to go and find your Azure App Service, for example, in a tool window, and then even right-click and attach a debugger if you want. But there's also support for Eclipse. So there are plugins for Eclipse that you can add that add in some Azure-specific functionality in terms of managing and deploying an application. So if you're working in Java and using Eclipse, you've got some tooling there as well. Visual Studio Code, more lightweight code editor from Microsoft that's free and open source, become very popular not just with Microsoft developers, but folks doing Node.js, JavaScript, and Visual Studio Code has an extension model, and there are a number of different extensions that you can add in to get everything from IntelliSense or template help with code files and code editing to extensions that allow you to go out and browse and work with your Azure resources to the point that you can right-click and deploy the code you're working on from Visual Studio Code. And again, in the Java space, IntelliJ is another tool that's got Azure extensions that can be added in to support a specific set of workloads, like building a web application and getting it set up and deployed out into Azure to test it out. Now, this list isn't exhaustive. If you've got a particular tool that you like and you use that to edit your code, chances are pretty good you can continue to do that. Use the package manager of your choice, depending on the language you're using, to pull in the SDKs. And then you'll be able to integrate on the build and deploy side once you're done testing that code locally. As I've mentioned, containers are very fast becoming a popular model for people to package up their applications and deploy and manage them. And typically, you do local development and use something like Docker to run containers locally so that you can do some local testing inside the container package, and you make sure that you're not testing completely outside of the environment you're targeting. And then when you want to go do integration tests or deploy it out in the cloud, you run it in Kubernetes out in Azure. And this works in many cases, but Microsoft has created Azure DevSpaces. This is something they've built on top of the Azure Kubernetes service. And you're essentially going to use the cloud to build for the cloud. You have an Azure Kubernetes service cluster set up and provisioned. You can have your application out there and deployed, but it's set up in such a way that the team can be working on the different services at the same time. So I might have one service that I'm working on, and I can, on my local machine, write some code, and then I can have it run out in the Azure Kubernetes service against the other services or the other parts of the application that are out there and deployed already. Then you may have multiple developers working on different services, each in their own branch of execution, basically. So it's very focused on the team. It's very much built for a group of developers to be able to work side by side with shared code that's out in the Azure DevSpace, but you get to test and work on the code you're working on in that environment. So you're not testing in isolation. You don't have to test against mocks. You're testing against the running code out in Azure DevSpaces. So if you're doing container development, you're going to be using Kubernetes, I would recommend you check it out and see if this is a fit for your team. As I mentioned, a number of the developer tools have the ability to build code and even right-click and deploy code, but that's probably not how you would do things in production. And the great thing about Azure is that for the most part, you can build with tools that are known to you. So if you have a build system in place today, a build server, for example, where you do continuous integration and continuous delivery, you can probably continue using that. And you can deploy using various options. So you can take advantage of Git and have a Git repository where your code is stored. And for some of the resources in Azure, you can set them up to be triggered where when a check-in on a known branch happens, that code gets pushed out to, say, your app service or your web application and put into production. You can also use those ARM templates. So whatever tool you're using to build your code and do your deployments, that deployment step can involve going out, taking those ARM templates out of source control, along with the parameter files, reaching out into Azure and provisioning the environment you're targeting, and then you can push your code out there. So if you already have a build process, like I said, you can probably continue to use that, adding in the specific steps to push things out to Azure. Part of Azure, however, is Azure DevOps, which is a full software development lifecycle set of tools that you can also take advantage of if it makes sense for your organization. We have Azure Boards. This is your planning, your work items, your bugs, all of that sort of tracking. And you have Kanban style boards that you can use on top of this to manage your projects. You have Azure Repos, so you can store your files out in Azure and the source control using Git or using the Team Foundation version control model that you may be used to if you've used Team Foundation Server on premises. Azure Pipelines give you build and release pipelines that allow you to do builds either on servers out in Azure or your own servers, and then release that code once it's built out into the different environments. And of course, it comes with various tasks around releasing or deploying your code into different Azure resources, whether that's containers or web apps or virtual machines or what have you. And there's Azure Test Plans. So you can document the test plans around how your code is going to be tested, what the different results are, and to track all of that. So if you need a full software development lifecycle tool set, or even just parts of it, you can take advantage of Azure DevOps for those services. Let's look at a couple of examples to give you a sense of some of the options you have in developing your code for Azure. One very simple solution may be that you want to write code in Node.js, and you're going to use Visual Studio Code to do that. And from there, you want to get that code, that web application, out into an Azure App Service. One simple way would be to use the extensions in Visual Studio Code and simply provision that app service and deploy it right from Visual Studio Code. Now, of course, you can replace this little orange arrow with a complete process where you'd check all that code in right from Visual Studio Code into a Git repository, and you'd have a whole build and release process behind the scenes to get you the same result of getting that code published out into the Azure App Service. Along the way, taking advantage of all these non-Microsoft tools and frameworks like Node.js and Git, and maybe a third-party build and release server. Another example, you may be creating a microservice solution. Using your developer tools like Visual Studio, you can go out and create your services, check those into a repository in Azure DevOps, and then use a build and release pipelines to take that source code, build it for you, and create container instances that you store in the Azure Container Registry. Then your release can go out and create a Kubernetes service, get a cluster all set up and running for you, and those container images then can be pulled down from the registry to be executed and hosted in that Azure Kubernetes service. And again, you can replace different steps in the process here, whether it's the repository you use or the build and deployment tool, but the ideas remain the same, that you use your development tools, you use your build and deployment tools, and you take advantage of the deployment capabilities to push these resources into Azure, both the Azure resources, such as an app service or an Azure Kubernetes service, and your code to get deployed onto that platform. So we've looked at some of the developer tools, talked a little bit about the SDKs. One of the key things I want you to understand is that from Microsoft's perspective, they're trying to build cross-platform, cross-language tools. So the Azure platform itself uses those HTTP accessible APIs to make everything accessible cross-platform and cross-language, and then you get SDKs and developer tools that enhance that experience for you. One of the great things is that as we start taking advantage of things like containers, we've got rich tooling around that, and even unique experiences like the Azure Dev Spaces that make working with containers a lot easier. And of course, we've got full support for the software development lifecycle, either through the Azure DevOps tools or through the tools that you may be using already on your own servers or on other hosted environments. Next up, we'll take a look at security in the Azure cloud.